right, CUET aspirants, let's get real for a second. That exam is just around the corner, and I know exactly what's stressing you out. Coordination compounds. You know those questions are coming, and you know they're a minefield for negative marks. But here's the thing. What if I told you it's not the complicated rules that are costing students their ranks? It's a simple mistake made in the first 5 seconds. A mistake that, after this, you will never, ever make again. So, let's fix it. Right now. Forget memorizing endless rules from a textbook. Together, we're going to build a simple, foolproof system. A mental checklist to get these questions right every single time. And you're going to want to stick around because I'm also going to reveal the secret Latin names that the exam setters use to trap even the top students. You're not going to be one of them. All right, let's dive in. Okay, first things first. This is rule 0, the absolute foundation. If you get this wrong, the rest of your answer, no matter how perfect, is worth nothing. You lose all the marks right here. I mean, think about it. You say sodium chloride, right? Not chloride sodium. It's the exact same logic. The positive part, the cation, is always named before the negative part. There are no exceptions to this, ever.
And here's how they trap you with it. The common mistake is seeing that Cl3 at the end and immediately naming it first. No! The pro move is to identify the entire chunk in the brackets as your cation, your positive piece, and you start your name there, period. Get this habit down and you've already avoided a huge mistake.
Okay, so you've got your cation. We're now inside that bracketed coordination sphere. It's time to name the ligands, and you guessed it, here comes the next big trap. Now, the first part is simple. Before you even think about the metal in the middle, you have to name all the little molecules attached to it, the ligands. That's the easy part. But what if you got different kinds of ligands? Like, you have some amines and some chloros. Do you just write them down as you see them? No way. This is where the exam setters catch the people who are rushing. And this is the trap. Your brain sees D for 2 and tre for 3, and it wants to put D before T in the alphabet. That's what they want you to do. But the pro move, you completely ignore the prefixes. You look at the ligand name itself. Amine starts with A. Chloro starts with C. A comes before C, so amine gets named first. It doesn't matter if there's 10 of them. Okay, quick mental check. Pause right now and think about this. You have aqua and amine. Which one goes first? Well, both start with A, so we look at the second letter. M in amine comes before Q in aqua, so amine comes first. If you got that, you've just dodged a bullet. Now, speaking of names, this list right here, it's non-negotiable. You have to burn these into your memory. They will not say ammonia in the correct answer. They will say amine. And look closely, amine has a double M. That tiny detail could be the difference between two options. I guarantee you one of the multiple choice options will say ammonia or water in the name. That is a freebie. It's a bait answer. You can cross it out immediately. Don't let that be you. Okay, time for a focus shift. We've handled the ligands. Now for the star of the show, the central metal atom. And its name all comes down to one single question. Is the whole complex in the brackets positive or negative? Listen up because this is a huge deal. If the complex part is positive or neutral, you just use the metal's normal name. Cobalt, platinum, nickel. Easy. But if that complex is negative, if it's an anion, you have to change the ending of the metal's name to ate. So cobalt becomes cobaltate, nickel becomes nickelate. This is a massive clue in your MCQs. Let's sear this into our brains. You see a negative complex, your mind should scream 8. And if you see 8 in an answer choice, you should immediately check if the complex is negative. This is your secret weapon to eliminate wrong answers fast. We're almost there. This is the final piece of the puzzle, the oxidation state. It's that little Roman numeral in parentheses right after the metal's name. You can't guess this. You have to calculate it. It's just a tiny bit of algebra. You look at the overall charge of the complex, you know the charges of the ligands, and you just solve for the metal. It's an absolutely crucial step. So let's do one right now. Pause and figure this out. The whole complex is neutral, so it all has to add up to 0. Amine is neutral, so that's 0. Each chloro is -1, and there are 2 of them, so that's -2. For the whole thing to be 0, the platinum has to be +2. So we write platinum II. Okay, you have the rules, you have the system. Let's put it to the test, CUET style. I'm about to show you a question that could be ripped straight from your exam paper.
Here it is, the same complex we just looked at. Let's find the correct name. Here are your options. Let's break it down with our system. D is out, metal is named last. C is out, the complex is neutral, so we don't use 8. Now it's between A and B, a classic alphabetical order trap, amine versus chloro. A comes before C, so the answer has to be B, diamine dichloropplatinum. 2. See? The system works, it just leads you straight to the answer. Okay, let's do one more, a full example from start to finish just to lock this whole process into your brain for good. Let's run the checklist. Step 1, cation first. That's the part in brackets. Step 2, ligands. 6 amines becomes hexaamine. Step 3, metal. It's a positive complex, so it's just plain old cobalt. Step 4, oxidation state. 6 neutral amines, 3 minus 1 chlorides. The cobalt has to be +3, so III. And step 5, the anion is chloride. Put it together, hexaamine cobalt 3 chloride. Boom, done.
Now, remember that promise I made at the beginning about those secret Latin names the examiners love to use? It's time to close that loop.
This is it. You need to screenshot this. When these specific metals are in a negative complex, you don't just add 8. They use their old Latin names. So iron isn't ironate, it's ferrate. Copper becomes cuprate. Silver is argentate, and gold is orate. Knowing this short list is what separates the top 1%. This is a pro tip.
Okay, that was a lot, but we've built the whole system. Let's boil it all down to a final rapid-fire checklist that you can use on every single problem. Here it is, your 4-point plan. 1, cation before anion, always. 2, ligands alphabetically, and you ignore the prefixes. 3, check if the complex is negative. If it is, use 8, and watch out for those tricky Latin names. And 4, calculate and write the oxidation state in Roman numerals. That's it. That is the entire game plan.
The only way this becomes automatic is if you use it right now. Go find a practice question, run this 4-step checklist, and prove to yourself that you've got this. You're ready to face any nomenclature question they can throw at you. Now go get those marks.